When does an analysis go wrong? Are false positives worse than false negatives? We will look at these questions and more as we delve into technical questions handling error that might be asked during a data science interview.
Okay, so I don't care who else tells you, but 2 plus 2 definitely equals 5. No, wait, no, that is, that right there is a false positive. Nope, sounds more like a false negative. I'm not sure which one it is, but which one is more important? Okay, so a false positive is never a good thing, but I can think of a few scenarios where it could be detrimental. For instance, if you were to provide vouchers to anyone who appeared to have spent a certain amount of time or money on your product, a false positive would be sending a lot of people vouchers who didn't earn them. We don't want that. It's better to not award an event in this case, since a few false negatives isn't going to cost the company as much money as a few false positives. I can totally cite a time where a false negative is totally more important than a false positive. So I can totally cite a time where a false negative is so much more important than a false positive. It takes me back. So, let's say you're working in cybersecurity. A false negative would allow hackers into your computer, while a false positive would simply annoy people who rightfully should be able to access your computer. The false negative could certainly be more damaging for a company should a product leak, or they decide to ransomware your computers. That is just so mean. Okay, fine, you got me. I think it's time where we talk about where a false negative and a false positive could have equal importance. Now, this happens in many cases. If you're ever handling money, such as for a bank, you don't want any errors in making loans. You lose the loan if you incorrectly trust the wrong people, but you also won't make any money if you incorrectly reject good people. While no algorithm can predict loan payback perfectly, you want to find a model that does so in a way that maximizes risk and reward. Risk and reward. Okay, if it's not too much trouble, could you just call me pretty? I just really need to be validated. I don't even know how to say it. Can we test that out? But what are the differences between the two? A validation set is a part of the training set used to help select parameters and avoid overfitting a model you're building. The test set is when you use for testing that model and ensuring that your model accurately predicts the data it trained in. In some cases, you can also skip the validation process, depending on your needs and the amount of data you're working with. But what is cross-validation? I use cross-validation to evaluate if my model will generalize to other data sets. This is done during the training phase of model building and helps me minimize overfitting and improve the accuracy of my model.
We hope this video helps you master the how-to behind data science. But wait, Don't forget to check out our other videos on data science, including theory, machine learning, and deep learning Q&As.